So yeah, hi guys, welcome to the next video that we are currently doing in a series. So today we are going to start a chapter quadrilaters. Like I've told you at the end of our earlier video, that was yesterday's video, I had told you that we are going to pick up with the chapter 8, and that is the chapter. We are going to start a chapter 8. This is quite an easy chapter. This will be relating to somewhat the portion of the chapter, I guess 3 from your class 8, which was already quadrilaters, right? You guys remember that chapter? In that chapter, we had understood the various type of quadrilaters, their properties, and what was the total sum of the interior angles of the quadrilateral, what was the total sum of exterior angle, what were concave quadrilaters, what were convex quadrilaters. So we had understood each and everything there, but I hope you guys will be remembering that. If you're not remembering that, if you cannot recall that, no worries. I have dedicated this entire video to that. We will be having some revision of that concept. Then we will come to this chapter. We will be having a lot of theorems in this chapter. Remember, we will be having many theorems. Let alone we have 8 to 9 theorems in just our first exercise. So remember, this chapter will be having a lot of theorems. You have to remember each and every theorem because that will be governing what shall happen with the type of quadrilateral, specifically your parallelograms, because those theorems will be coming handy while you attempt a chapter 9, which is area of triangle and parallelogram. So remember, each and everything that you are going to learn in this chapter, that will be very important. You cannot skip anything in this chapter. And also remember, there will be some concepts of your chapter, some concepts of the chapter 7 that you have already learned, which was your triangles, right? So if you are having any doubts in that chapter, so just go back to the video. You can do what? You can just log into our website or download our application, get yourself registered, have the recorded sessions there, watch it again, have proper notes, read them out, have practice questions. So you can do a lot of things. You just have to download our application and you just have to get yourself registered. So without wasting any more time, I'm going to start with the video. So very first thing, quadrilaters. So what are quadrilaters? You guys remember, a quadrilateral, quad means 4, lateral means side. So any four-sided figure will be termed as a quadrilateral. It can be a parallelogram, it can be a rectangle, it can be a square, it can be a rhombus, it can be a kite, it can be a trapezium, a trapezoid or isosceles trapezium. There can be anything. But remember, four-sided figure with four vertices and four angles, that will be a quadrilateral. Now you guys remember, while you were dealing with your polygons, right? You had this three-sided polygon was your triangle. The word itself stated the same thing. Tri means three, angles means angles. So three-angled figure, or you can say three-sided figure, that was a triangle. Then you had four-sided figure, that was quadrilateral. Then you had five-sided figure, that was pentagon. Then you had six-sided figure, that was what? That was your hexagon. Then you had seven-sided figure, that was septagon. Then you had octagon, eight-sided octa, nine-sided nona, and 10-sided decagon. So we had a lot of things. We had 11-sided figures too, but these were the common types of quadrilaters or polygons. Sorry, polygons, not quadrilaters. These were the common type of polygons that you should be remembering in order to have their names in your mind. So when I talk about quadrilateral, the first thing that should come to your mind is this, that they will be having four sides, they will be having four angles, and they will be having four vertices. Now we will be relating the relationship between their sides and angles. Which type of side in a quadrilateral, if opposite sides are equal, then which type of quadrilateral will that be? We will be having a lot of various forms of quadrilaters, like your rectangle, your square, kite. I've already discussed the names here, so you guys must be remembering that. So there will be a lot of type of quadrilaters. So for that, I'm gonna do what? I'm gonna start with the video and let's move forward. So introduction. First point is 4 points in a plane such that no three of them are collinear. That means if you have four distinct points that are lying in a plane, if you join all those 4 points and such that none of those, actually not three of those 4 points are collinear, then the figure will be a quadrilateral. Two can be collinear. See, these 2 points are lying on the same line, they can be collinear, but 3 points cannot be on the same line. If that is the case, if you have something like this, let's say this is the figure in which 3 points are collinear and one is distant. So you guys see, this will be what? Let me just do it again. So if 3 points are like this, they are collinear, and you have a fourth point which is distant. So you guys see that figure will be what? That figure will be a triangle. So remember, if you are talking about a quadrilateral, so all its four sides have to be, actually all its four vertices have to be distinct. None of them has, actually not three of them has to be a collinear point, a pair of or a triplet of collinear points. So this will be the main point right here. Then a quadrilateral is made up of four lines. It has four sides, four angles, and four vertices. This is what I'm trying to tell you from the very beginning of this chapter. There will be four lines, so you can say four sides, four angles, and four vertices. And sum of angles of quadrilateral is always 360. Now for this, you should be remembering the sum of all interior angles. Your interior angles, it was what? N minus 2 into 180. That was the formula to calculate the sum of any polygon. So you guys know, if you were talking about a triangle, it had three sides. So 3 minus 2 into 180. That was what? That was this. That was 180. And you guys know, sum of all three angles of the triangle is always 180. If you were talking about a quadrilateral, so it will be what? Let's see. 4 minus 2 into 180. So it will be what? 2 into 180. That will be what? That will be 360 degrees. Although we will be proving this also with an example, considering a figure and dividing it with the help of a diagonal. And we will be proving with the help of the angle sum property of triangles, two triangles there, and we will be proving that the sum of all interior angles of a quadrilateral is 360. That is the main thing. I'm going to move forward and see the quadrilateral's basic facts. Let's just cover them up. Four sides. If I name this figure, see A, B, C, D. So I have four sides which are AB, BC, CD, and DA. Right? It has four vertices. Now you guys know what are vertices. They are the points where any of the two sides actually meet each other, or actually they separate from each other, or they emerge from there. So you guys see, it will be what? It will be this A, B, C, and D. So these are what? These are the four vertices, right? Then we have four angles. So four angles will be what? Angle A, angle B, angle C, and angle D. And such that angle A plus angle B plus angle C plus angle D. If I add all of the four angles, their sum will be what? It will be. So these are the basic facts regarding a quadrilateral. Now we are going to do what? We are going to move forward and study the types of quadrilateral. So you guys see convex quadrilateral and concave quadrilateral. So by definition, a quadrilateral is called a concave quadrilateral if at least one of the line segment is lying on the inside, or you can say if you join its opposite points and its diagonal falls on the outside. Now you guys see, if I just look at this figure, I have this figure A, R, W, O. If I join A and O, you guys see this diagonal, these are the opposite points, right? If I join two opposite points and the diagonal ends up being on the outside of the figure, that type of quadrilateral is your concave quadrilateral. Okay. And talking about the convex one, if you join the opposite points and all of the two diagonals there lie on the inside of the figure, those points are what? Those figures are your convex quadrilaters. So see, a quadrilateral is called a concave quadrilateral if at least one of the line segment joining the vertices is not the part of the same region. That is what has been told here. So if you join two vertices and the line, which is in our case AO, is not the part of this quadrilateral, that means AROW, it is lying on the outside. So this will be a concave quadrilateral. While you're talking about the convex one, if you join any of the two vertices and all of the sides, any of the two opposite vertices, that will be the accurate term here. So if you join any of the two vertices and you end up getting a diagonal, this is the diagonal, right? Diagonal is a line that joins two opposite points. If you join two of the its opposite vertices and both of the diagonals end up being inside of the quadrilateral, that type of quadrilateral will be your convex quadrilateral, right? So remember, the type of quadrilaterals that we are going to deal with today are always your convex quadrilateral. So if you talk about a square, so square is like this. If you if you join its diagonals, so both of the diagonals are on the inside. Similarly, you can talk about rectangle, diagonals will be inside. If you talk about trapezium, diagonals will be inside. So if you take any type of quadrilateral, the diagonals will be inside, and all of those type of quadrilaterals are your convex quadrilaterals. I hope you guys understand this and you don't have any doubt in this portion. So these are the two types of quadrilaterals. Now we are going to do what? We are going to move forward and see what do we have now. Let's move forward and see. So angle sum property of quadrilateral. So this is, now we are going to prove Why the sum of interior angles of a quadrilateral is 360. Now for this we have taken a quadrilateral ABCD such that we have joined AC, and this is a diagonal. It is dividing the quadrilateral into two equal parts. Now I know if I add angle 1 and angle 2, I will be getting angle A. If I add angle 3 and angle 4, I will be getting angle C. And if I just focus on triangle ABC, I have what? Angle 1 plus angle 2 plus angle B. That will be what? That will be 3 degrees, right? That should be 3 here, actually 4 here. Angle 1, angle 4 plus B. That should be 180 degrees because angle sum property of triangle, right? Similarly, if you talk about ADC, so in triangle ADC, angle 2 plus angle 3 plus angle D, that should be 180 as well. So if you add these two, angle 1 plus angle 2, that will be angle A. Angle 4 plus angle 3, that will be angle C, plus angle B plus angle D. 180 plus 180, that will be what? That will be 360. So you guys see sum of all four angles of a quadrilateral is always 360 degrees. I hope you guys understand this and you don't have any doubt in this. So that will be the point right here. So sum of all interior angles of a quadrilateral is 360. Bear with me. This is very important. They should be asking you in exam if they want to. That prove that the sum of all interior angles of a quadrilateral is 360. So you can use this method or you can use that property or the formula to calculate the sum of interior angles. Although that is not necessary, you can use this and easily prove that sum of all interior angles of a quadrilateral are 60. I hope you don't have any doubt in this, right? Now let's move forward and study the types of quadrilaterals.